In the first part of this chapter, we learned how to calculate risk and return measures for a single investment at a time. And you may remember that we had 5 different investments ranging from a T-bill to 3 different stocks. There was the stock of the high-tech company, the collections company, U.S. Rubber Company, and then there was a special investment called the market portfolio. And we saw last time how we could calculate the expected return and the standard deviation for each one of them. So we could get some measure of at least the average rate of return and the level of risk for each of those investments by themselves. Now, the key there is that I said by themselves. Alright, now in reality, most rational investors do not just hold one thing at a time. They do not just pile all of their money into one stock. And there's a good reason for that, because if you pile all of your money into one security, then you risk that stock becoming perhaps the next Enron. And then of course you subject yourself to the risk of possibly losing everything. And if you hold a diversified portfolio, that is extremely unlikely to ever happen. Oh, don't get me wrong, you can still have some losses and maybe even some maybe even some significant losses, but actually losing all of your money would take something like a nuclear holocaust, which of course if something like that were to happen, we would have bigger problems than just figuring out the value of our stock portfolio. So anyway, it is smart to diversify, and later on we'll talk about a little bit more of the reasons why you would want to diversify. But anyway, we have just nailed down the fact, or kind of settled the fact, that yes, most investors do not just hold one stock at a time, they hold a portfolio of stocks. So it would be a good idea for us to know something about the risk and return of a portfolio instead of just knowing about the risk and return of one stock at a time. So in order for me to introduce this idea to you, what I would like to do is do something really simple. Let's just assume that we have a portfolio of not hundreds of stocks, but let's just say 2 stocks for right now. And let's say that we have created this portfolio by investing $50,000 in the high-tech stock and $50,000 in the collections company stock. So again, it is a 50-50 mixture. It is exactly a half and half mix between the high-tech stock and the collections stock. Well, as it turns out, the expected return of a portfolio of 2 individual stocks is actually just a weighted average of the expected returns of those 2 stocks, if that makes sense. In other words, the high-tech stock, as we calculated last time, has an expected return of 12.4%. And you can look back in your notes previously to see that that is true. The collection stock, if you calculated that, would have an expected return of 1%. That's also back previously in your notes. And so it follows that if I combine these 2 stocks in a portfolio, then the expected return of the portfolio would be somewhere in between the expected returns of these 2 stocks. So somewhere in between 12.4% and 1%. And in fact, because this is a 50-50 mixture of the 2 stocks, it'll actually be halfway in between, exactly halfway in between, which will end up being about 6.7% if I remember correctly. Now, when I was taking my first finance class, I remember having a very similar discussion like this. I remember the instructor pointing this out, and I remember not being at all surprised that this was the case. But I do remember being kind of surprised by what happens with standard deviation. You see, I expected in an example like this that the average or the expected return would just be a weighted average of the expected returns of the two stocks. That was no surprise at all. But getting the standard deviation, I kind of thought it might be the same way. I kind of thought it might be just a weighted average of the two standard deviations. But I was most certainly mistaken about that, because it's not quite that simple for standard deviation. But don't worry, I'll show you how standard deviation would be done very shortly. And it's pretty much just the same techniques that we used in the first part of the chapter, but you're going to see that something more happens with standard deviation that actually is beneficial to the investor. So, what I'd like to show you first is how we do the expected return of the portfolio of these two stocks. Now, I don't know if this formula here looks a little bit possibly intimidating to you, but what we have is a summation from I equals 1 to n of the weight of each stock in the portfolio times the expected return on that stock. Again, the little Greek letter there, actually the big sigma, represents a summation of different things, and in this case we're summing n things. Now, what is n in this example? Just 2, because there's just 2 stocks in this portfolio, so we're just adding up 2 things in this case. But if you had like 100 stocks in the portfolio, then n would be 100, but that's certainly not the case here. We're just dealing with 2 things, so it's a simplified example that should introduce this point pretty nicely. So what exactly are we adding? Well, in each case, that is for each stock, what we're going to do is multiply the weight of that stock, which is represented here by WI, and we're going to multiply the weight by the expected return on that stock. Now, what exactly are these weights in the equation, this W sub I that comes up? Well, it's really simple. It's just the percentage of your money in the portfolio that is invested in that particular stock. So remember that in this case we have half of the money invested in each stock. So it's pretty simple. The weights are just 0.5 for the first stock and then 0.5 for the second stock. So certainly nothing unexpected or complicated there. Now, notice, of course, that if we had put a little more money in the first stock, for example, and a little less money in the second stock, well then, let's say, for instance, that we put $70,000 in the first stock and only $30,000 in the second stock. Well, then this wouldn't be a 50-50 mixture. This would be a 70-30 mixture. So this number would not be 0.5, it would be 0.7, representing 70%. And this number would not be 0.5, it would be 0.3, representing 30%. But anyway, that's not the case. This is a 50-50 mixture, so those weights are 0.5 each. And then we also have to put in the expected returns of each of the 2 investments. So 12.4% for the high-tech stock, 1% for the collection stock, and that's about it. So we take the expected return on high-tech, which is 12.4%, multiply that by the percentage of our money that is in the high-tech stock, which is 50% or 0.5. So 0.5 times 12.4%, that is going to be 6.2%. And then, of course, over here we've got 1%, the expected return on the collection stock, times 0.5, which that would make 0.5%. So we add the 6.2% over here to the 0.5% we just calculated, and of course we get the 6.7%, and that's the expected rate of return on this portfolio. So exactly halfway in between 12.4% and 1%, and that's kind of what I expected would be the case, and I don't think that's a tremendous surprise, really. Okay, so Um, Let me show you another way that you could do the same thing. There is another way that you could get the expected return on this portfolio. And here what we're doing is actually getting the probability distribution for the portfolio itself. Now you might remember from the first part of the lesson here in this chapter that we had a big probability distribution where we listed all of the possible outcomes for all 5 of these different investments, the T-bill, the 3 different stocks, and then the market portfolio. Now in this case we are just taking that information for the 2 stocks in question, the 2 stocks that make up this portfolio. There's the high-tech stock and then there's the collection stock. So this probability distribution shows you the possible outcomes for the high-tech stock and for the collection stock, and it shows you the 5 different states of the economy and of course the payoff or the return to each stock in the event that each one of those states of the economy were to occur. And of course, like any probability distribution has to, it also shows you the chances of each outcome occurring. And this is just taken from the table that we saw in the previous part of chapter 8 as well. So how exactly do we do this? You see there's one extra column here. The rightmost column in boldface is for the portfolio of the 2 stocks. That is the 50-50 mixture of each. And so how do we construct that column? Well, it's actually pretty easy. We just go line by line through this table here, and we see that, let's say in the case of the recession, the high-tech stock would earn negative 27%, and the collection stock would earn positive 27%. So we take a weighted average. It's a 50-50 mix, so 0.5 times negative 27%, and then 0.5 times positive 27%. Add those 2 together, and of course you will get 0%. The positive and the negative will exactly offset each other. Now what about the below average case? Well, let's take a look at that too. You would have still the 50-50 mixture of the 2 stocks in this portfolio, so 0.5 times negative 7% is negative 3.5%, and then 0.5 times 13% is positive 6.5%. So you've got negative 3.5, positive 6.5, that adds up to positive 3, positive 3%. That's the portfolio return in this particular state of the economy. Then you could do the average case, and that's a 50-50 mixture again. Let's see how that would go. 0.5 times 15% would be 7.5%. And then of course here you'd have 0.5 times 0, which is just 0. So you've got the 7.5%. That's the portfolio return. You could continue on down and do the same exact thing for each line of this probability distribution, and you would see what the portfolio would return in each possible state of the economy. So then you would go through and do essentially just what I showed you in the very first part of the chapter, and you would look at each of the 5 states of the economy and what the portfolio would pay off in each case. So let's see, in the recession state there would be a 0% return, and the chance of that happening is 0.1, so you've got 0.1 times 0%, and of course that's just 0%. Then in the below average case you've got a 3% rate of return, and there is a 0.2 chance of that happening, so 0.2 times 3% is 0.6%, and you could just continue this on down. Take that weighted average just like I showed you how to do for the individual stocks. Basically it would go like this. Notice that you've got 0.1 times 0%, and then 0.2 times 3%, and then for the average case you got 0.4 times 7.5%, then above average you've got 0.2 times 9.5%, and then finally for the boom case you've got 0.1 times 12%. You do that for all 5 cases and you've got the 6.7% expected return for the portfolio. And this shouldn't be a surprise to you because we already calculated the portfolio's expected return using a slightly different method earlier, and we got 6.7% there as well. So it's definitely not a coincidence, and in fact mathematically these two methods have to give the exact same answer. So now we know how to find the expected return on a portfolio of 2 stocks, and if we needed to do more than 2 stocks we certainly could. We would just apply pretty much the same method.